Good morning, everyone. So, we welcome all the viewers who are watching us. This is the final interns demonstrations of their group project that they have did, and this will be their last presentation for this internship. After this presentation, their internship will be over. So, that is all from me right now, and I will be handing over to the interns so they can showcase their project to you guys, as well as they can demonstrate as in the show what they have learned throughout the internship and how this project they have developed, like this is a practical project that they have Good developed morning, as a everyone. team, how So, that project will help other we welcome security all the professionals viewers and who are other watching people us. who This is the love to final use interns
or
demonstrations of of their their group group project project that or they have they did, know how we can automate, and this will be there's a their lot of things
last
we as a security
presentation for this
professionals
internship.
we
After
requires to be
this
automated, like
presentation, their
nobody wants
internship will
to
be over,
learn.
or nobody
So
wants to do
that is
anything
all
manually.
from me right now,
So
and I will
all
be
of
handing
that will
over to
be
the interns
done
so
and
they
demonstrate
can
by
showcase
the Cyber
their
Ledger
project to
interns.
you guys,
Now,
as well as they can
without wasting anyone time,
demonstrate as
let's
in the
begin
show
the
what they have learned
final
throughout the
project
internship and how
demonstration.
this
Handing over
project
to the
they
interns
have
now.
developed, like this is a practical project that they
Good
have developed
morning,
as
everyone.
a team, how
So,
that project will help other
we welcome
security
all the
professionals
viewers
and
who are
other
watching
people
us.
who this is the
Love to
final
use
interns
or
demonstrations
love
of
to
their
use
group project
project that
or
they have
they
did,
know how we can automate,
and this will be
there's
their
a lot of things
last
we as a security
presentation for this
professionals
internship.
we
After
requires to be
this
automated, like
presentation, their
nobody wants
internship will
to
be over,
learn.
or nobody
So
wants to do
that is
anything
all
manually.
from me right now,
So
and I will
all
be
of
handing
that will
over to
be
the interns
done
so
and
they
demonstrate
can
by
showcase
the Cyber
their
Ledger
project to
interns.
you guys,
Now,
as well as they can
without wasting anyone time,
demonstrate as
let's
in the
begin
show what they have
the
learned
final
throughout the
project
internship and how
demonstration.
this
Handing
project
over to the
they
interns
have
now.
developed, like this is a practical project that they have
Good
developed
morning,
as
everyone.
a team, how
So,
that project will help other
we welcome
security
all the
professionals
viewers
and
who are
other
watching
people
us.
who this is the
Love to
final
use
interns
or
demonstrations of
love to
their
use
group project
project that
or
they have
they
did,
know how we can automate,
and this will be
there's
their
a lot of things
last
we as a security
presentation for.
professional.
Yes, you're audible.
Which process would then all the problems look directly path analysis. The project general demonstrates that misconfigured account can be changed if other weakness to achieve complete to overcome initial resolutions to all the way from document the users the government credentials. The project covers the following topics such as the network and user emulation, ASREF, blockchain attack, and then the packet tracking, assembly lateral movement and credential harvesting, TCC privilege escalation, and low down data collection. So automatic attack path analyzing using gap that I use Python script to do it. Uh, on the Active Directory, it's from a Trihackney lab rooms where I used to Windows Server 2019 government controller. in the domain name of uh, local. The system exploits common Active Directory services like Corpus, LDAP, SMEs, uh, HDP, and WinRM, which uh, which which confirm it was a domain controller and have multiple attack surface to analyze it. When any attackers or threat attackers perform any kind of attack, first step is on reconnaissance, especially on network enumeration. So I started with the scanning open ports on open ports and services that open port services that that has been covered much more like the tax office with ports and which services are open, like this gives a common view of what kind of attack is possible here. There are a bunch of I have used. First, I use Nmap for port scanning and service with fingerprinting. Then I use Nm for Linux for assembly or LDAP enumeration. Then I use Corvus for Corborous username enumeration. Then I use impact get NP users for ASRP hosting. Then use John for password tracking. Then NHC for SMB shares and Bloodhound data collections. Then I use SMB clients for SMB share interaction. And packet script dump for DCC, credential dump. And then Python based network text to perform graph based attack path analysis. With the network enumeration stage, I found especially 6 ports, that is uh, 6 ports, uh, which having services of DNS, then Corborous, then LDAP, then SME, RDP, and WinRM. Then the second stage will be user enumeration. That I use a tool called Corvus to enumerate valid usernames through Corvus response. This was helpful because it allows me to find real users in the domain without locking accounts or uh, needing any kind of passwords. There I found several valid accounts like James, SPG, hyphen admin, Robbins, administrator, backup, Darkstar, Paradox. This is the first step of attacking threat because in which valid usernames are important like it's a starting point for multiple virus attack. Then as roasting after identifying valid users like valid users. Uh, I used to get NP users from infected to perform their self roasting. Uh, this kind of attack works when an attacker has a Corborous peer authentication is disabled. If it is enabled, then it doesn't work here. Uh, after performing the commands, the account SPC-RBIN has pre-authentication disabled. So I captured it, I found the hash, and then I crack it using John the Ripper. Uh, then I recovered certain credentials like that users and the passwords, that is management of 2005. This is a weak password. Uh, this really shows two things. The first one is the account was misconfigured, and the second one is the password is weak enough to crack. Like I need to jump it cracked like within some seconds. Then I perform assembly lateral movements with SVC and Arvin credentials. I checked assembly shares using net exit, and then access the back share using assembly client. Inside that share, I found inside that share, I found a file called backup credential.txt, which is encrypted with basic, not encrypted, that's encoded with basic, which is not called as encryption because it can be easily. This was the major finding because the credentials were stored in a share that we accessed with low privileges. Then I performed this in privilege escalation. The backup account had a decision privileges, which means it could be request directory replication data from domain controller. Uh, Using secret DOMs, I performed the decision operation that under DOM the domain credential access, including administrator entry access. Uh, this is the one of the most dangerous configuration in Active Directory because it means a non-domain controller accounts can replicate and extract password access from the entire domain. Here's the entry access. The full attack chain of how the attack can be occurred. First, initial access, then initial access happened. For initial access, we for you to discover valid usernames. Then for SRP roasting, where the SPC SPC-admin has a pre-authentication disabled. So I capture hash from SPC-admin and crack it, then it shows the password of SPC-admin. And then lateral movement happens. For lateral movement, I have access to SMB shares to uh, attractive directory slash backups, uh, where where I found a plain text backup underscore credential directory. Page 64 coded. After coding, I found the password of backups. Then privilege escalation happens. The backup account has DCC rights. So using a in-packet secret dumps, you can get all NDS.DIT handles. Then got domain compromise. After getting administrative access, the pass is to pass the hatch. Then full domain control has been occurred. After collecting bloodhound data, so this command, I wrote a Python tool called Pathfinder.py using network X. The script build a graph from the bloodhound JSON data from bloodhound JSON data and searches for shortest path from users to domain admins. Like a the script the tool outputs like it helps visually and logically identify the attractions that may not be obvious during manual analysis. Uh, if, as seen in the output, you can see that the administrator has a direct path to the domain admin, and the spokes also has direct path to domain admin. It was helpful because it shows that uh, there may be hidden privileges in the domain, even if they are not immediately identified. Data and nothing. Uh, Findings. Kerberos pre-authentication was disabled on service accounts, so its severity is high. Its impact was ASRP has captured and tracked. And in a second, they used weak passwords like within a Rocky or any other word list. We can crack it in seconds or minutes. It's, it has also, due to weak password, it has also high severity. Then they have a plaintext credential in SC shares, which is critical, like the backup account has been exposed. Then the backup account granted recessing privileges, like a low privilege user had a recessing permission, which is also like critical. Uh, Due to this step, full domain credential drop has been happened. Then using the bloodhound analysis, it can reveal that the Facebook is the domain admin member, which has high severity. Due to this, hidden admin path has been discovered. To prevent this kind of attacks, like organization should enable uh, Corvus pre-authentication on all accounts. Like they need to disable UF down record pre-auth unless they need that kind of permissions. And organization must enforce strong password policies. They need to avoid storing selling shares like assembly shares, even encoded one. Need to restrict decision rights. only to approve necessary accounts like the domain controllers and the organization to regularly perform drawdown to find a bug and then to fix it. Then then the organization need to place privilege account in the protected security groups.
Please don't stop. Carry on.
I think it's complete. Sir, any questions regarding this?
Is the final demonstration over?
Yes, yes.
Aiden and Jaden.
All right. So I am up next. 1 second here. Short slideshow and a short demonstration. Oh. Slideshow's a little longer than I intended. We're going to try and go through it faster. So I had the misconfiguration hunting portion of this project. The summary for mine is the goal was to automate the identification of critical misconfiguration in Active Directory. I created a component that parses through sharp-hound JSON data through a custom logic engine and transforms data into an actionable audit report. This helps streamline the work of security professionals and allows the detection of high-risk vulnerabilities before they're exploited. Some of the core detection capabilities are looking for excessive user rights, unconstrained delegation, ASREP roasting, machine count quota, and outdated operating system. So moving on. Our first one is the excessive user rights permissions. Our primary ACE flags that we're looking for, these are our high impact controls. The main one is generic all, which grants full object control, including password resets, group, and computer takeover. Then we have generic write, which permits updates to non-protected attributes. This is used for curve roasting a lot. Write DACL, which allows the modification of security permissions and enables users to grant themselves full control. Write owner, enabling ownership of an object, subsequently overwriting its security settings, and all extended rights, which covers sensitive tasks like DC sync attacks and administrative password resets. We have lateral and local and lateral movement rights. Admin 2 identifies accounts with local administrative privileges on remote systems. Can RDP tells us which users can use remote desktop protocol. SE remote interactive logon rights. This is the underlying user rights assignment, or URA, that enables RDP access. And then can PS remote pinpoints users authorized to execute remote commands through PowerShell. And then we have the hidden control relationships, which is add member, which is found in group objects, which allows the addition of users to a group to inherit its total permissions, and force change password, which explicitly allows resetting the target's password without knowledge of the original. Moving on, we have security risks. For privilege escalation and lateral movement, we have the attack path, which can compromise standard accounts. High-level ACEs like generic all allow for rapid escalation to domain admin and network traversal, which misconfigured group nesting and overprivileged service accounts provide threat actors with the key they need to move through the network. For the increased attack surface, we have target density, because more privileged accounts create more high-value targets for credential theft and malware deployment. We have hidden risks. These are inactive or service accounts that have debug program rights, and this allows threat actors to hijack system-level processes. We have insider threats and privilege gaps. The abuse of access, disgruntled or negligent employees can leverage excessive rights for data theft, fraud, or intentional sabotage, and permission accumulation, where privilege creep occurs when rights aren't revoked after role changes, leaving dangerous, undocumented access paths open. Then for compliance and operational impact, we have audit violations. Excessive unreviewed permissions violate regulatory standards, leading to financial penalties and data integrity, where overprivileged accounts, often lacking MFA or frequent password rotation, are primary vectors for unauthorized modification of data or deletion. So then we move on to mitigation and operation risk. I'll spend a little less time on this one here, but for the core mitigation strategies, we should police privileges, protect high privilege groups, tiered administrations through hardened separate accounts for administrative tasks, delegation of control. You can use the AD wizard to assign specific limited rights. Secure service account should be group managed service accounts, GMSAs, to automate password rotation. Then we have operational best practices. Account lifecycle management. We should regularly audit and remove inactive, disabled, or stale accounts. Restricted groups. We can automatically remove unauthorized users from critical security groups. Lapse implementation, which is local administrator password solution, which can randomize local admin passwords. And active monitoring. ADDS auditing and monitor for sensitive rights DS replication get changes to detect DC signal. So then the logic for this portion of it is we have the identification strategy, which looks for, the function looks for users that are in the list from the JSON files, and it pulls property names for reporting and looks for specifically into ACEs, which are access controls, entries, arrays. We filter for dangerous rights. We look for high-risk ACE flags like generic all, generic right, right DACL, right owner, and all extended rights. Deduplication, we use the set flag here to store found rights. This ensures that even if a user has multiple instances for a specific right, it's only flagged once per user. And then reporting and output. Conditional flagging. Vulnerability entry is only created appended to the flag listed in the found rights set is not empty, if the found rights set is not empty. And structured data includes the specific username, vulnerability type, and a list of the exact permissions found in a human readable description. Our second one is insecure delegation. We have three types. There's unconstrained delegation. The mechanism, the server can impersonate any user who authenticates to it, forward those credentials anywhere in the network. We look for unconstrained delegation true Boolean within the properties block of the computer and user objects. And any non-domain controller with this flag is a high value target for harvesting ticket granting tickets from privileged users. For constrained delegation, this restricts impersonation to specific services, but still remains usable if the service account becomes compromised. For this, we identify the allowed to delegate edge or the MSDS allowed to delegate to attribute. If an attacker gains generic right or generic all over and with these rights, they can escalate to the specific services listed in the SPN attribute. And then resource-based constrained delegation. The target resource, such as a computer, defines which accounts are allowed to delegate to it. For this, we identify allowed to act edge, which maps to the MSDS allowed to act on behalf of other identity attribute. And with this, attackers can write permissions over a computer object and can modify the attribute to point to their own account, effectively granting themselves administrative access to that machine. The risks for this are we have full path to domain compromise with ticket harvesting through unconstrained delegation. Attackers can extract the ticket granting tickets from memory using tools like Mimikat and use it for impersonation. Once the TGT is stolen, the attacker can impersonate that user, and this includes domain admins to any service in the forest. For advanced lateral movement and coercion, attackers can exploit legacy services to force domain controllers to authenticate to a compromised, unconstrained machine. This immediately hands the DC's credentials to the attacker. And then we have credentialless traversal. Because delegation allows the service to act as the user, threat actors can move between systems without needing to crack or steal actual passwords. And then we have persistence and infrastructure, where we have stealthy persistence. They can impersonate high privileged users and create backdoors and persistent access that appears like legitimate activity. And machine account exploitation. This risk isn't limited to user accounts. Compromised computer accounts with delegation can impersonate other sensitive machines that often hold high-level domain privileges. So mitigation and defense in depth for this, the core strategies include disabling unconstrained delegation. We should transition systems from trusted for delegation to do not trust this computer for delegation within ADUC. We should enforce modern delegation where it's required, replace legacy unconstrained methods with resource-based constrained delegation, RBCD, to strictly limit impersonation scope. Account hardening, we should enable the attribute account is sensitive and cannot be delegated for all high privileged accounts to explicitly block impersonation. In protected user groups, we can add admin account to the protected user security group and enforce non-catchable credentials and restricted delegation. We then have specialized threat mitigation, where we can block coercion paths by disabling the print spooler service on the DCs to prevent attackers from forcing the DC to authenticate to a compromised, unconstrained server. And then permission audit. We should regularly monitor users and groups, hold the rights to enable delegation, as this privilege is often a silent path to domain compromise. And we can see down below we have that unconstrained is legacy and very insecure is critical because threat actors can impersonate any user to any service. For constrained, it's moderate, can still be abused, and is restricted to specific services, but still abusable. And then resource-based is most secure. It's denied at the target, and it's definitely the hardest to exploit. And then we have the logic engine for this. First, we scan the users, and this can be adapted for computers for within the SharpHound dataset. This looks for the properties object, which contains Boolean flags for various Kerberos settings. The script checks for the specific unconstrained delegation key, and it verifies if the value is explicitly true. In AD, this corresponds to the trusted for delegation flag under user account control or UAC attribute. And then reporting, we have high risk tagging. Every account identified is labeled with a high risk warning in the description due to the potential for credential harvesting. And automation benefits. This replaces the manual effort for hunting through thousands of lines of JSON. We have number 3, ASREP roasting. First, we have the identification property. JSON indicator. The parser searches for the don't require pre-auth true key pair value within the properties block for user objects. This property maps directly to the don't require pre-auth flag within the user account control attribute of AD. The attack mechanism for a credentialless request, attackers only need a valid username to request a Kerberos ticket. They don't need authentication in the domain. encrypted response. The DC sends the ASREP response and contains data encrypted with the user's password hash. And this can be used for offline cracking, as threat actors can capture this response and use tools like Hashcat or John and crack the password. Then we have common root causes. This includes legacy compatibility, which often left enabled for older applications that don't meet modern Kerberos pre-authentication. Server account misconfigurations are frequently found on service accounts where security settings are overlooked during setup, and account migration oversights, where artifacts left from the migrating accounts between domains and folders. And then we have defensive strategies and security risk for this. The critical security risk is zero credential entries, as attackers don't need an existing domain account to perform the initial request. KDC exploitation, or Key Distribution Center, is forced to return a TGT encrypted with the user's password hash before identity verification occurs. Offline stealth, and because this is the intense hacking happens on the attacker's local machine, it bypasses network account lockout policies and SIEM alerts. And this is high impact because it frequently is utilized by advanced persistent threats, or APTs, for rapid lateral movement and initial credential theft. For detecting and mitigating this, we should enforce pre-authentication, since the primary mitigation strategy. We audit and disable the do not require Kerberos pre-authentication setting for all user accounts through Active Directory users and computers, ADUC. PowerShell auditing, we can identify these vulnerable accounts using get AD user filter does not require pre-auth EQ true. And then we can use event monitoring, configure alerts from Windows Security Ident 4768. This is Kerberos ticket requested, and pay close attention to the instances where pre-authentication is bypassed. And lastly, we have password complexity. For any legacy accounts where the setting is functional requirement, extreme password complexity to make offline cracking next to impossible should be enforced. And then we have the logic engine for this. This one processes the users array within sharpbound JSON output and isolates the properties block of each user object to check for authentication requirements. The logic specifically hunts for a don't require pre-auth key, and if the value is explicitly true, the script identifies that the don't require pre-auth bit is flipped in the user's account control settings. Impacted users are categorized as under the ASREP roasting vulnerability type, and this generated report explicitly states that the user is ASREP roastable, providing immediate context for blue team remediation efforts. Now we move on to number 4. We have the machine account quota. The identification looks for domains.json file rather than the individual user or computer files. It looks for the machine account quota key within the properties block. And while the default value is 10, any value greater than 0 is flagged as a vulnerability. This is because when this quota is active, any authenticated user can join new computer objects to the domain without admin approval. SPN generation, because created machine accounts automatically receive a service name, or SPN. This is a critical prerequisite for advanced Kerberos attacks. And this is most commonly leveraged as a first step for resource-based constrained delegation, RBCD attacks, which allows the attacker to grant themselves admin rights over a target system. And then we have the attribute mapping. The LDAP attribute in the live Active Directory environment, this property maps directly to the MSDS machine account quota. It identifies this at the domain level and provides a global health check on security posture regarding rogue device registration. Security risks for this include unauthorized network foothold. Attackers with standard user credentials can spawn up to 10 computer objects without admin approval. These machine accounts are legitimate AD objects, which makes them silent and makes them blend in with standard network traffic. At the advanced exploitation paths, with RBCD foundation through creating a rogue machine account. This is the primary prerequisite for RBCD. Attackers use these accounts to configure delegation rights and impersonate high-privileged users. And shadow credentials, attackers can inject credentials into a new machine object. And this enables certificate-based authentication or exploiting vulnerabilities such as CVE 2022-26923 to impersonate DCs. And then we have privilege escalation and persistence. Group membership, new computer objects are automatically added to the DC group. If this group has been granted local admin rights on specific servers or workstations, attackers can immediately inherit those permissions. And this gives them permission through rogue machine accounts because they give a stable long-term access point that's often harder to detect. So then, so to mitigate this and harden against it, the first thing we do is set the quota to 0. Use ADSI edit, adsi-edit.msc to locate the MSDS machine account quota attribute and change that value to 0. This immediately prevents non-privileged users from creating rogue computer objects. Delegated administration, we should, instead of using domain-wide defaults, we should explicitly delegate create computer object permission. Assign this right only to authorized personnel, such as help desk, and restrict it to specific organizational units or OUs instead of the entire domain. And then we have monitoring and auditing. Event logging, monitor Windows security event 4741. This is a computer account was created, and any instance of this should be tagged by a non-admin account. Any instance of this being triggered by a non-admin account should be treated as a high priority alert. And then we should audit the MSDS creator SID attribute on existing machine accounts. This reveals exactly which user created the computer object, which allows us to identify accounts spawned by unauthorized users. So for the logic engine for this, we look for the domains array, as this quota is a domain-wide configuration instead of a per-user setting. This targets the properties block of the domain node to find specific quota limits. The script is designed to handle different sharphound output versions by checking for both the simplified key, machine account quota, and the formal LDAP attribute name, MSDS machine account quota. It uses a logical OR 0 to ensure the script doesn't crash if the property is missing, then triggers the flag only if the value is greater than 0. The output identifies specific domain name and the exact quota limit allowed. And by including the actual number of allowed machines, this helps admins understand the scale of their risk. And our last vulnerability is unpatched domain controllers OS version. First thing we do is we look through computers.json, but as a critical filter, it only evaluates objects where the property ISDC is set to true. The logic utilizes two primary strings for verification. We have the operating system, the friendly name, such as Windows Server 2012 R2, and operating system version, which is the specific build number, such as 6.3/9600, revealing the path, the patch level, or service pack status. Then we have detection criteria. The script performs substring matching and looks for legacy platforms that don't receive security updates. This key targets include Windows servers 2000, 2003, and 2008 R2, and Windows Server 2012 R2, as these are critical as they recently exited the extended support. By checking the version strings, the logic can identify if a modern OS, like Server 2016 or 2019, is running an early unpatched build vulnerable to known exploits such as zero logon or NoPack. And then the last bit is systems running end-of-life software are permanently vulnerable to critical flaws such as Eternal Blue because vendor patches are no longer released. And even on supported version, older build numbers indicate a failure in the patch management lifecycle. which leaves the organization's identity root exposed to well-documented escalation paths. Security risks and impact of this are critical security risks identify root as risk, since the DC holds the entire identity and infrastructure. The compromise here is total domain takeover. Weaponized vulnerabilities, because end-of-life systems are permanent targets. Once a patch cycle ends, the known flaws remain open forever. Legacy protocol exposure. Outdated OS versions have insecure protocols like NTLM v1 and SMB v1 enabled by default, which are the primary vectors for attacks like WannaCry and vulnerabilities like Eternal Blue. And modern security updates like Kerberos pack signatures can actually break communication between patched and unpatched DCs. This can lead to widespread authentication failures across the forest. Operational and performance impacts include the security software blind spots, because modern EDR and endpoint detection and response and antivirus solutions often lack support for legacy kernels. Instability and inconsistency, because running an mixed OS versions or inconsistent cumulative updates or CUs levels can lead to corrupted Kerberos tickets and replication errors between sites. And then we have performance bottlenecks, because older OS builds aren't optimized for modern virtualization or hardware. And then we have legal and compliance dangers. Most regulatory frameworks like GDPR, HIPAA, and PCI DSS explicitly forbid the use of unsupported hardware. End-of-life DC is an automatic fail on a security audit. And then liability. In the event of a breach, running known vulnerable unsupported systems can be classified as gross negligence, which leads to significant financial penalties and legal liability. Mitigation and hardening for this. First, we should utilize network isolation and control. With VLAN segmentation, we can move outdated DCs to dedicated isolated VLANs to lateral movement. We should block all outbound internet access from DC subnets. And if connectivity is essential, we should use a proxy with strict DNS filtering. And then we should use host-based firewalls to block unauthenticated DCE or RPC traffic and limit communication only to necessary and authorized systems. Number two, we have protocol service hardening. We should kill legacy protocols like SMB v1 and NTLM v1 and move towards restricting NTLM entirely in favor of Kerberos. Disable the principal service on all DCs to close off frequent privilege escalation paths, and manually enforce SMB signing and LDAP channel binding to neutralize man-in-the-middle attacks. Administrative and security controls include tier administration. A tier 0 model for DCs ensures that high-privileged credentials never touch less secure workstations. With PAW implementations, we can require DC management to be performed from privileged access workstations, dedicated hardened endpoints that have no other purpose. And then identity protection, we can use Windows Credential Guard or LSA protection to save credentials and memory from harvesting tools. And then we have the strategic exit plan. We should avoid using in-place upgrades. Instead of upgrading the OS to an existing potentially compromised DC, we can promote servers running modern operating systems like Windows Server 2022 to the DC role. Once the roles are migrated, demote the legacy DC and perform a thorough metadata cleanup in AD to remove all traces of the old system. And then we have ended. This processes all the computers arrays from the SharkHound output containing metadata from joined systems and puts the operating system string from the properties block to compare against known lists of vulnerable platforms. Rather than looking for an exact match, the script iterates through an outdated versions list. And because this catches various editions like the standard and data center in R2 that share the same name with the vulnerable kernel. This list includes not just legacy Windows servers, but also end-of-life client OS versions and common Linux distributions like Ubuntu 14 and 16 and CentOS 6 and 7 that might be hosting domain services. And then null handling, the script handles a safety check. If not OS name, continue to ensure the parser doesn't crash if there's no available names. And then this outputs the vulnerable machine to its domain name, which is vital for a multi-domain forest actionable intelligence. By including the exact OS string found in the description, we can provide immediate evidence for IT teams to begin decommissioning isolation. And with that, I have a short demonstration. Okay. So then we can cd to sleuthhound directory. We can see here that there's the JSON files from the sharphound data, and then we can simply just run python 3 sleuthhound.py, and that tells us immediately we loaded the users, computers, and domains JSONs. We loaded 40 computers, 40 users, 12 computers, 1 domain, and it shows us that they were all saved. From here, we can change to the output file, and we can see that they're all here. If we just look at asrep roasting.json, we can, apparently there's, there. If we just look at the flags.json, we can see that this compiles all of the different ones. So like we can see the generic right owner, right DACL, all extended rights, generic all. This flags file will put everything together, but the individual ones will, there we go. So we can see here. So I don't have any available ones to show for some of these, because I'm using just a generic test file for the sharphound output. But yeah, and on the on here there is instructions on. There's the file itself that you can download. There's hashes to check, and instructions and requirements for what you need, as well as the source code if you would like to populate the file yourself. And with that, I am done with my portion, and I'll move it on to Jaden.
Hi, so what I have is the remediation and reporting portion, and let me pull up this one. All right, so I have domain sleuth and remediation and reporting, and so this part basically focuses on building a remediation and reporting engine. It's able to transform security findings into actionable intelligence. So the goal is to detect misconfigurations and vulnerabilities within an Active Directory environment and contextualize them in terms of risk, exploitability, and impact. So the final output is a structured PDF report that presents prioritized remediation guidance and highlights potential attack paths that lead to domain compromise. And so the tool basically takes security findings, either manual input or information from the flags JSON file, and it will process them through a remediation engine, and it will identify relationships between findings and attack paths and allow it to prioritize issues based on real risk rather than isolated severity. So first, research and remediation logic. So the remediation logic was designed based on common Active Directory attack techniques and defensive best practices. So each finding type was mapped to a clear description of the issue, the potential impact if it was exploited, actionable remediation steps, severity, exploitability, and confidence levels, as well as MITRE attack technique mappings if they're applicable. Key finding types. So the key vulnerabilities and finding types that you'd see is DC sync, and so this would be critical. This would be a critical finding. So it's basically when research shows that replication permissions are able to be abused to extract password hashes from the domain controllers. And so the remediation would be to restrict replication permissions and audit privileged accounts. For Kuberostable accounts, which has a high severity, it's when service accounts with SPNs or service principal names are targeted for offline password cracking. So the remediation would be to enforce strong passwords and rotate credentials, as well as use managed server accounts. And then for ASREP roastable users, this is a high severity. This is when accounts without Kuberos pre-authentication allow attackers to retrieve encrypted data for for offline attacks. And so the remediation is to enable pre-authentication and enforce strong password policies. Generic all permissions is when full control over objects. There is full control over objects, and so this basically allows an attacker to reset passwords or modify permissions, and that also in turn allows lateral movement. And so the remediation would be to remove excessive permissions and enforce least privilege policy. For weak configuration, it's high severity, and it's basically when a group has overly permissive memberships or members, and this increases the attack surface and allows privilege escalation. So the remediation is to audit restricted group membership using role-based access control. And then for unconstrained delegation, it's high severity. This basically allows credential impersonation and Kubernetes ticket abuse. And so the solution or remediation is to replace with a constrained delegation and monitor ticket activity. For inactive privileged accounts, which has medium severity, it's when dormant accounts with elevated privileges pose a hidden risk. So the mediation is to just disable or remove inactive accounts and implement lifestyle management. For the attack path to domain admin, this is critical. It's basically a sequence of misconfigurations of permissions, and it allows an attacker to escalate their privileges from a low-level account to a domain admin. And so this is basically a direct path to full domain compromise. So the remediation is to identify and then break the chain of attack by removing unnecessary permissions and restricting access between nodes and enforcing least privilege across the path. And then for weak password policy, it's a medium severity. It's when domain password policies are basically allow users to have short, simple passwords. And so this obviously increases the chances of brute force or credential-based attacks. And so remediation is to just enforce strong password requirements, enable complexity rules, implement password history, and configure account lockout policies. So attack path analysis. So a key feature of this part of the application is the ability to interpret and explain attack paths. Attack paths are essentially sequences of relationships that attacker could exploit to escalate privileges. So this function essentially accepts user-defined paths. So it could be like user to service account to domain admin, and then converts them into step-by-step explanations, identifies the weakest link within the chain, and then provides remediation insights to break the path. Plus, findings are correlated with attack paths to determine how many escalation routes a single vulnerability supports. So this allows prioritization based on real impact instead of isolated severity. Risk scoring. So the risk scoring system combines severity weights, which is critical, high, medium, and exploitability factors, which is easy, moderate, and hard. And each finding contributes to an overall score. The model also categorizes overall risk into critical, high, medium, and low. The calculate risk score function evaluates the overall security risk by assigning weights to each finding based on its severity and exploitability. it loops through all the findings and calculates a weight scored for each and sums them to produce a total risk score. So the function also counts how many findings fall into each severity level and also determines an overall risk rating based on the presence of higher risk issues. So the final score is capped to prevent excessively large values and is used to summarize the organization's overall security posture. But some additional features are quick wins, and this identifies fixes that reduce risk the most. Top priority fix, which is to highlight the most impactful issues, and then risk reduction simulation shows how fixing a finding changes the overall score. So risk scoring ensures the report reflects both technical severity and practical risk reduction. So the PDF report generation is implemented using Python's report lab library, and it constructs a structured readable report with multiple sections. And so the report structure is essentially the executive summary, which is just how many findings there are and the risk level. The risk scoring dashboard, which displays the total amount of findings, severity distribution, and overall risk score with color coding. And then quick wins, as said before, it's just highlights remediation actions that yield the greatest reduction in risk. Top priority fix, again, identifies the most critical issue and provides focused remediation guidance. Attack paths, this section explains escalation chains and also suggests how to break them. And then the detailed finding is basically the findings and it having detailed information, which is the severity, which is color coded, the MITRE technique mapping, if it applies, confidence and exploitability, description and impact remediation steps, attack path impact if it applies, and simulated risk reduction. Some design highlights would be modular functions. These are separate. It uses separate functions to handle remediation logic, scoring, attack path analysis, and PDF generation, data validation, and duplication. This basically is what ensures consistent and a clean report output, as well as dynamic content generation. Sections like the attack paths and priority fixes only appear when they're relevant to the input. And then styled output, it's just using heading, spacing, and bullet points to have improved readability and keep the reports professional. Some key features would be correlation between findings and attack paths, risk-based prioritization rather than static severity, simulated remediation impact on overall risk score, integration of MITRE attack mappings, and dynamic and structured PDF reporting. So these features move the tool from like just vulnerability listing to more actionable security analysis. So overall, this portion demonstrates this part of the application demonstrates how raw security data can be transformed into actionable security data, actionable intelligence. So a key takeaway is not all findings are as important, but context such as attack paths, exploitability plays a critical role in determining the risk. Plus, building the risk scoring system highlighted the importance of balancing accuracy and usability. So a purely technical score is not enough. It has to clearly communicate impact to impact. So now I will go ahead and do a short demonstration of the tool. So this is what the report essentially looks like. So it'll have DomainSleuth security report, executive summary, risk scoring dashboard. This is for, I believe, one finding. This is the score of the finding. The finding was critical. So quick ones would be to fix privilege escalation path to domain admin. This would basically reduce the risk completely because you got rid of the path of escalation. So the attack path is from John Doe to IT admin, from IT admin to service admin, from service admin account to domain admin, and domain admin access is achieved, and so now they have access. An attacker has access to the domain. And so the remediation restricts access between John Doe and IT admin to break this change. And then here's the detailed findings for privilege escalation path to domain admin. And now I'll show you how I would run the report. So you have the option to use a JSON file, which would likely be the flags.json file. So we'll do generic all. Source, we could say any user, so John Doe, and then we could do IT underscore support. Add another, we'll do attack path. As well, we'll do John Doe. IT admin again. Service account admin. And then it would result in domain admin access. And then we'll also add, we'll just do those two. And then you have this here as well as the actual report. So you get an output in the terminal. And then you also have the structured report with more detailed information. And so now we have a risk score of 150 because we have two critical findings, two risks that are critical. So we have fixed excessive permissions now for generic all. And then the top priority fix in this case would be excessive permissions. So this matters because attackers could compromise John Doe, leading to lateral movement and potential escalation. It provides recommended action, which would be to remove the generic all permission and then restrict access as well. It has the attack paths for the attack domain finding as well as the final impact. And then we have detailed findings for both of the vulnerabilities that we put in. They're both critical. Excessive permissions is the MITRE technique. T1098, confidence for both is high, exploitability is easy. It has a description for both. This one's the attack path. This one's the control that the user account has over another account. The impact is also shown and how it affects the system, as well as remediation options. So fixing this issue would break one attack path, generic all permission, restrict access, everything I covered earlier, and also shows how much the risk score would reduce due to fixing this issue. And so that's it for this. So thank you all for listening. Have a nice day. I believe that's it.
Thank you, interns, and thank you everyone for watching. We will meet soon again. Have a great day, everyone. And that is our wrap up.